In this video, I'm going to try and provide you with a basic and simplified explanation of cathedral or vaulted ceilings and why we don't remove ceiling joists or rafter ties, and just go ahead and, why you can't, I should say, remove ceiling joists and simply put drywall the bottom of the rafters if you don't have the right type of framing. Now, a regular roof system like this, conventional roof system here, the weight is actually that is in a downward motion is going to be applied to the rafters and the ridge and can actually force the walls out. It can bow these walls out and create a dip in the center of the ridge. And the reason for that is because there isn't anything tying it together. With the ceiling joists and the rafter ties, you're creating a connection from one side of the wall to the other side of the wall. So as the weight is placed on the weight, just the basic weight of the roof by itself, I'm not talking about adding snow or debris onto the top of the roof. The weight that would be transferred in this area here, this part right here, is going to want to force the wall out. It's going to want to push it out and let this sag down. Now, with this setup right here, I'm not about to suggest that you're not going to get a sag in the roof. If you have rafter ties or ceiling joists and the center of your ridge or parts of your roof are sagging, that would probably have something to do more with the engineering of the materials. Maybe they're not the right size. Let's say you have a 2x6 rafter that's sagging. It might have needed to be a 2x8. So this right here, typical way to frame a roof, conventionally framed roof with a flat ceiling. Now let's take a look at another common way that you would frame a cathedral or vaulted ceiling without ceiling joists or rafter ties. Now this way right here is going to require a ridge beam. And I'm going to show you two methods. This method right here and the next method I will show you will be where I raise the ridge up. So this particular method right here, the rafters are going to lap and connect to each other. The other one, the ridge, they will connect to the ridge. So in this one right here, let's take a look at how the load would be distributed. The load from the roof is going to set on the beam, and then it is going to come down the supporting post on the side here. Now, with this system right here, you aren't going to have the weight of the roof is going to be, or any load on the roof is going to be transferred between the wall and the supporting beam and on both sides. So you're not going to have the walls spreading out on something like this. And I'm not suggesting you can't have the wall spread out. I've actually seen it on longer walls. But the rafters themselves will actually help to prevent the walls from spreading out, because this is where the tie is. The rafters will actually form a nice bracing system, let's say, and keep the walls from spreading out, because the weight on the rafters, the load that is transferred onto the rafters, isn't going to be moving the rafters down, creating a sagging ridge, which of course would force the walls out. That's actually supporting the walls. So the ridge beam is actually supporting it. With no movement down here, you're not going to get the walls to spread out. And I hope that makes sense. Let's take a look at how we would connect the rafters here. This is actually lapping the rafters. You would nail into the rafters, maybe put 3 nails on each side, something like that, and then you would install some ridge blocks. And of course you would have seat cuts at the bottom for the rafters, and then finish the end off with a, let's just go ahead and take a look at finishing the ridge off. sorry about that. You'd basically just have two rafters that would line up at the end of the ridge. Here's the other method I was referring to. We would have the rafters attaching to the ridge, and then of course the posts and the beams. Now I wanted to point out here I have a post that's sitting on top of a wall. We have a supporting post under the wall. Over here the post goes all the way up. I would imagine both methods would be fine, but because this method right here creates a break in the structural break that would need a strap. You would need to put a strap on the wall on the other side. And this one right here, you're just transferring the weight down, but you could actually create a hinge point here. A lot of engineers don't like to see it. They'd rather see the strap on the wall with a full-length post than something like this, but I'll leave that up to you. Remember, this is the basics. I don't want to get carried away here, even though I just did. What the heck? So, roof rafters that attach to the ridge beam instead of going over it. Something like this will give you more area if you're looking for a taller ceiling. And sometimes you can use larger rafters if you want the ceiling to be flat. You don't want to be able to see the ridge beam. Don't forget, too, that the rafter sizes will depend upon the insulation you're going to be using or your local community requires. So a lot of times we used to use R30, which was, I believe, 9.5 inches or 10 inches, and we could put the R30 in the 9.5 inch wide roof rafters. We could use them with that. We couldn't use them with 2x8s, and every once in a while I'd come to a job where they would have 2x8s on a remodel, and it would create problems for the insulation. So keep that in mind when you're designing your roof system also. So this is just the basic seat cut, give you an idea. In this video, I am going to try and explain where water can actually come from, where it can actually enter into a building. I know a lot of times we see water damage in a certain spot, and we think that the water is coming in right from the other side. That's not always going to be the case. Now, with a concrete block wall, I want to point out that concrete blocks can absorb moisture. If the moisture is absorbing in through the waterproofing on the exterior, then it can actually be absorbed into the wood. The wood will actually pull the moisture out. So you might come to a spot where you have more damage to a bottom plate than you would to the framing, and that actually might be something to consider when you're trying to figure out where this water is coming from. Another thing I'd like to point out is that water can travel horizontally from right to left or from left to right, front to center, front to center to front. It can travel underneath the plywood. So the water can actually be coming in here and then going over here. And this creates a lot of problems for trying to figure out where these problems are coming from. Here we can see that water has came all the way over to here. It looks like this whole area here has been wet, goes all the way over to here. You could be thinking that the water is leaking from directly above, and that's not going to be the case. It could be coming from another point. So again, this is where it gets confusing. Just because you see a lot of damage in one spot, this does not necessarily mean that this is where most of the water is coming in from. Could be coming in from another area. This is what the person who sent me the email, this is where they said the point of entry is. Of course, this looks like where it would be the most damage. Now, for those of you who paint something on a basement wall, some type of waterproofing system, or even some type of just a paint to cover everything up. Once the paint starts peeling off, this could be a suggestion that the water, you have a problem with water. Water tends to absorb into block. It has no place to go. It seems to cause the paint to separate from the block. So you're going to see stuff like this. This is the exterior, and you can see they have a gutter here. And the gutter's probably catching a lot of the water. The gutter's preventing the water from going and into the ground around the exterior of the basement wall. So this is a good idea. And here they have another gutter picking it up, entering into this one. Looks like they got a really good system here. One more thing I'd like to point out is that the roof shingles are sagging here. They look like they are not supported. So the roof sheeting, there could be a problem with the roof sheeting here. So you're going to need to check this out. Now the damage is down here. And it would make sense to think that, hey, wait a minute, maybe the water is leaking in here and I've got a waterproofing problem with the basement. And you actually could. You could actually have a waterproofing problem with the basement. But the thing that, and this is where it gets tough, this is, you will actually need to probably remove some of these parts and start looking for any gaps or cracks where water could be leaking into. And it depends on how bad this leak is. If it's raining, been raining outside for about 3 hours, and you go in your basement and it's soaked, then you're probably going to find a bigger hole. But do not be confused. The biggest problem I ever had was a skylight, and it had a 1/8 of an inch by 1/8 of an inch, possibly a 1/4 inch in diameter hole, and it was like someone had the hose faucet on. This thing was leaking like a son of a gun, and that's all it was a spot. I filled it with roof sealant and never had the problem again. What a nightmare. This is what you're looking for. This is what you're going to be looking for. The siding up here tells me that there are plenty of places for water to enter into the waterproofing system. In the back, you have all of the wood trim is perfect for water to enter. Water will actually roll over the metal, and it looks like they have metal here over the wood trim. It'll actually roll over and around the metal and on top of the wood, and then behind the waterproofing. It's just not uncommon to see something like that. So the point of entry for the water could be anywhere along the roofing where the roofing butts the house. Could be any point of the where the wood and the stucco, any gaps here. Could be anything above it. Remember, water is going to leak down, and then it could leak all the way down. You could actually have moisture in the walls up here, and depends on how much water is leaking through here. And the water can actually be going over some of the waterproofing system, and then finding an easy path. And maybe the easiest path is right in the corner. Maybe they have some sheeting on the outside, and there's a gap in the sheeting between the sheathing and the waterproofing material or water resistant material like building paper, and it's you got a nice little hole leading it into there, and it funnels it all down to the bottom. Here's another view of it, and I don't think that it's coming. The bricks or the rock here, the stone, could actually be discoloring or changing color because of the moisture here. We can actually see that this looks like it's a little more moist than this area over here, but it's hard to tell. Looking at this, I guess this is all moist here. So you could actually, the damage here could be coming from the interior water leak, or it could be being pulled out of and absorbed from the soil into the block and being pulled up. I've seen this stuff pull up as high as 3 feet. Do not be misled. Let's go ahead and take a look at what it would look like before it was framed. Before it was wrapped with the building paper and finished. A lot of times these problems right here, this is a big problem area. This is actually why most builders use this type of a system. They will come in and put some type of a high-grade ceiling, a building paper. It might be this is the product. I hate to use the names, but we used to buy a product called bithethane, and I really don't know what you would call this. I guess you could read it right there. Building products, who knows? But this is good. This is a peel and stick. And you can see they didn't peel anything off because they don't want it to stick to anything. They're going to come in later and run the building paper underneath this so that anything that runs off of this will run onto the building paper. Now, I know this video is going to be a little long, but the whole purpose of this video is to give the individual some ideas on where the water can be leaking from, and hopefully it will help others. And you can always visit the website for more information. So this right here is a great idea. Now here's the bad news. This isn't something that every builder does. So the builders who know better do this. And I actually used to use 2 to 3 layers of building paper here. I'd put it in there, but this is way better to do something like this with a better product. Here's the section of the house that we're going to take a look at in a little more depth. Now here's something where water can leak in. Let's just say you do not have this right here. Or somehow it's leaking from the poor installation of this and the sheet metal. So let's pretend like we don't have this here. The water comes off of here or off of here, goes into the gap here. We've got the building paper covering this, but somehow it's getting behind the building paper. It can travel horizontally great distances. It can travel down and come in any gaps in the sheathing. It's going to look for the easiest path of least resistance, so if the building paper is squashed up against the face of the shear panel here and the water is leaking and it builds up in this area, but it's not it's got a little too much resistance because the building paper has trapped the water on the inside, then this is going to be an excellent place for it to travel. This is where it gets to be a problem. You can actually have a water leak over here and 6 feet away have the water damage. So finding the water leak is going to be the key to solving the problem with all of this. You just can't go in and fix the damaged area. You've got to fix the area or the problem area where the water's actually coming in from. So this type of setup right here where you have a roof that intersects into a wall is a tough thing. It really is. So there are a few things you can do to prevent the water from leaking here. But and this is a biggie, if you don't have something like this behind the roof framing that butts into the other wall, then there's a good chance you're going to end up with a leak. Here's what it would look like with some of the building paper installed. Got the building paper, and then of course the next layer of building paper will go underneath all of this here, so that the water that leaks off of it will go onto the building paper. But don't be confused. You can actually, you could see that this part right here isn't sticking out very far. Wouldn't have been a bad idea if the builder ran it out about 12 inches, and they probably thought, this is going to be enough. And maybe it will. It's definitely better than nothing. But you could see where water could somehow come in here, and most horizontal. So if you had let's go to the building paper. If you had a break in the building paper like you do here, usually the building paper underneath it or over it, you need to have a 12-inch lap. That's a 1 foot lap. That's minimum for any water traveling down here, because you can have water that gets behind the gap and it might only come in 6 inches before it comes down and out the weep screed. If that's the case, something like this, you could see, let's go back, you could actually see where if the water was to leak off of here and kind of go over 6 inches, now it's off of the paper. Now it's going to get behind the paper. If it was to come back behind the paper 6 inches on something like this, you're probably not going to have a problem. If it was to somehow build up to where it's going to be forced to go horizontally, now you could end up with a problem. And who knows, because if that's the case, this stuff could be 12 feet long and you could still have a problem with it. Here's what it would look like after it's finished, and I know you really can't see it very good, but you can see the building paper is running at an angle, comes down here, and then they have building paper underneath it. And this is an area where the lather for whoever installs the building paper really is going to spend a lot of time and make sure that everything is done right. It's not uncommon, and I think we can see it right here. You can see some of the bithurethane, or the rubberized product that's over the building paper. The building paper goes underneath it, and you can't see it over here. That's because the first layer of building paper goes underneath this and then probably goes all the way over to here. But either way, it's going to have at least one piece of building paper underneath everything, and then, pardon me, the next piece of building paper would go over it, which is what we have here. You can now see this is a full piece of building paper going all the way over to here, probably coming right up. So you don't get to see how that's finished off 100%, but that is more or less how it's going to be finished. So let's go ahead and go back to here. And with the information you just have that I just gave you, you can get a pretty good idea where the water could be leaking from. Or how it could enter into one spot right here, let's say, and then create a big problem. Now, if you're getting a lot of water and it is near a roof, most of the time it is going to be the roof. And this doesn't look like a large area where the water is going to be leaking from. If you had a roof, let's say, that was 20 feet from the front edge to the peak or the ridge of the roof, now you're getting a lot of water. This doesn't look like it's getting a lot of water, but it doesn't mean that it's not getting enough water to actually create a problem. So to do a repair like this, I hate to say it, the first thing you're going to need to do is start tearing some stuff apart. To fix something like this, the stone might need to be removed. And depending on where the water leak is. And how are you going to find this water leak? It's like I said, you're going to need to tear some stuff apart. I would try and start in this area here. See if this is damaged. If there's some type of termite damage, then obviously the water could be leaking in from that. Or if there is termite damage, this could give us a clue that we have a lot of water coming in, or a lot of water hanging around for a long period of time. Might need to do something about that. But you're going to need to see if there's flashing underneath the shingles. If there is no flashing underneath the shingles, and again, I have other videos on that. If you need more information, I can put some links in here or direct you to those videos. Go to the website, go to roofing repairs, roofing, check out the stucco, look at the lath, some of the lath videos that are on the stucco repair and the stucco under the home building section at the website for more information. So I hope this helps. Finding the water leak, I could go on and on all day about what you would need to do. But it's going to be forensics. It's not going to be easy. I would start in this area right here and see if you can find any gaps or cracks. If you don't want to take the stone off, then you're going to need to try and work in this area and see if you can redivert the water flashing. This gutter might actually need to go farther over, or it might need its own downspout to go all the way down. The problem could actually be right here with this gutter, depending on, what I just said about the roof. Well, I guess we can take that away. This could be getting a lot of water if it's taking all the water off the roof up here. If that's the case, you might want to redivert the gutter, have its own downspout, or somehow move the gutter over to where it's going right down into the downspout. It's not on the roof. And now that I look at this, I hate to say, this actually could be your biggest problem, because you can have a spot where the water can come in, but if it's only 2 ounces of water an hour, because there's not a lot of water coming into that area, then you're not going to have as big of a problem as if you have 2 gallons of water coming into the area. And this is where something like this downspout could actually create a problem like that. Could have so much water it's backing the gutter up, it's splashing it, and this could be the problem why the wood is rotted underneath the eave, if that's why these shingles are actually leaning down. So here's another question that was sent to me. The individual has water damage in a basement, and it's right above a porch that has concrete on it. And this is basically what the framing would look like. Here we have some soil, the basement walls, the floor framing, and a little bit of the wall framing. And I went ahead and removed the section of the basement wall here to give you a better view. Now, the damage that they seem to have in the pictures that they sent me seem to be along the beams and a little bit of the floor joists. And this wouldn't be uncommon. It would be more common to have damage around the edges of the porch where you're going to get a little more water than you would through the center most of the time. So, and don't forget, water damage, you can actually have water damage right here. It can be right above these joists here, let's say, and it travel farther. It can travel and make a bigger mess here, and this is where you think the water damage is, and it's actually back farther. So if the home is level, the floor is level, and the water can travel quite some distance. I've actually seen it travel on roofs, probably about 15 feet, and away from where the leak actually was. You could end up with the same problem here. Don't forget that. Let's go back up on top and take a look at what the waterproofing should look like. And, of course, the set of stairs and the porch. I wanted to just give you an idea of what the stairs look like to give you a visual of where the problem could be. Now, the problem is going to be more than likely, like I said, the water's going to be coming in through the sides, and it could actually be coming in from behind the paper also, behind the building paper, that would be applied over the waterproofing for the siding or the stucco. And if you need more information on that, take a look at our website and go to the stucco section and look at lathing, and that'll give you an idea of how the waterproofing paper or whatever membrane you're going to use to protect the exterior wall framing and that would go behind the stucco or behind the siding actually looks like. So with that said, let's take a look back at the waterproofing. The most common place for it to be damaged will be at the edges, because wood expands and contracts, buildings settle. There's a variety of different things that can cause these materials to fail. Of course, one of them would be poor installation, inferior materials, and its worst enemy, of course, will be time. In the last section of the video, I went ahead and raised the concrete stairway to give you an idea of what it would look like, kind of a snap in place. If you just remove this, lowered it down, you would snap into place. This is what it would look like. And just kind of going around the back here. Another view underneath, give you an idea. This is what it would look like. And there's the waterproofing again. So here's the bad news. If you do have water leaking from a porch area like this, something that is framed like this, there's a really good chance that it's the waterproofing. Now remember, I'm just making this as a suggestion. You would actually need to verify it somehow by doing a little more homework or contacting a professional in your area, a contractor or something like that. The damage most of the time is going to be from the waterproofing, as I mentioned earlier. The bad news is that the stairs are going to need to be removed, and the waterproofing redone. This is probably going to be the biggest reason for water damage if you actually have a framed system over a basement or a floor or a garage that looks something like this. This is part 2 of the previous video. I will put a link in at the end for part 1. And this is basically going to give you a better idea of how to create a better product if you're going to be pouring a concrete porch, over a waterproofed area, which would be over a wood-framed floor or basement. So here we have the waterproofing. First thing I would recommend would be to put some type of a foam expansion board. I don't know if you want to use concrete expansion board. This is actually, the whole purpose of this would be to allow the concrete to expand and contract and without creating problems. So let's just say you used a 1/4 inch or 3/8 inch foam, and this would be foam you could get at most home improvement centers. And the concrete expanded. It's going to push the foam, it'll compress the foam a little bit instead of putting a lot of force on the framing. And in some cases, I would imagine, I'm just guessing, I've never seen it because I haven't dealt with too many situations like this. I would imagine it could actually push the framing apart a little bit. You know, we're not talking about an inch, maybe a 1/4 of an inch or 3/8 of an inch. And if you've seen something like that, feel free to leave a comment in the comment area. All of my videos are based on my observations or the observations of others that make sense. They are not based off of fantasy, so I'm not about to speculate and get all dramatic here on how much something like this of a problem it could create. So I would imagine if you had something between a 1/4 inch and a 1/2 inch of foam or some type of a concrete expansion material, you would be fine. And then, of course, you could pour the concrete porch or stairs, whatever you would be pouring or installing. Now, after you have the concrete installed, and I've seen people actually do this before the concrete was installed, but to me, why not? Pour the porch, get it in there, and then have them install the siding. But I've actually seen people go in and install the Z-bar or the L-metal, I should say. They install the L-metal, and then someone comes in and finishes the concrete stairs. That's not something I would recommend doing. If you had to, I understand you're in a situation where you have to do it. That's fine. But to me, it would be waterproof, pour the concrete, and then do this part as I'm showing you. Now, this would be L-metal, and I'm going to try and make another video to provide you with how you actually install the L-metal, how it laps properly. And if I haven't made one in a while and I haven't put a link in here, feel free to leave a comment in the comment area and I will get on it. But something like this might actually involve me purchasing some metal and showing you in a video instead of using the software here that I'm using. So we would simply put some metal in to put the metal in so that the water, any water that gets behind the siding can actually go out instead of down behind the waterproofing here. So the metal here, even though it's on top of the waterproofing, any water that gets behind the metal is still going to go down the waterproofing and out. It's not going to be a really big deal as long as the waterproofing holds. So let's go ahead and take a little tour of the metal and the waterproofing, give you an idea of how it's going to look. Now, one thing I'd like to point out is that you are going to need to install some type of a sealant underneath the metal here. I've seen people, they just go and they just put a bead of sealant on the front, and that's fine if you want to do something like that. What I would recommend would be, before you put the piece of metal down, simply put a bead of caulking down and then squish the metal into the caulking. And do not smear it. If the caulking sticks out, if it squishes out, install the metal, let the caulking dry, and then cut it off with a knife. If you try to smear it here, this could turn into a mess and really look horrible. So just a thought there. And if you need more help on that, I can always provide you with another video on how to install the caulking. Next up, you would need to install the building paper, and it's going to go over the metal. So what we have here is the waterproofing, the metal, and then the paper. The paper is going to protect or provide us with a protective layer for any water or moisture that gets behind the siding. It's going to get behind the siding, come down, and roll off. As long as this area is sealed underneath the metal, it's going to roll onto the concrete. And in some cases, it's going to absorb into the concrete. But again, we can't solve every single problem. And if you want to put a sealer on your concrete for something like this, I think it would be a mistake, because any water that does get trapped below isn't going to be able to get out. So not something I would recommend, and I hope that makes sense. So here's the siding, and this siding could be plywood, could be lap siding, tongue and groove, shiplap, whatever. It could be anything. This principle here basically applies to, can be used with a variety of different types of siding. So another thing I would recommend, to leave at least 1/4 of an inch gap between the siding and the metal flashing. Water will pool up in these areas. And now you're probably thinking, well, what about dirt and debris that gets caught in there? Clean it out. You've got to clean this stuff out. Now, one of the biggest problems with something like this, and I swear it just irritates the heck out of me, but it happens all the time. I cannot believe how many times I've built something and a painter comes along, and this happens, and it might not be during the original construction, but later on, a painter will come in and they'll caulk this area, and that is a no-no. The minute that you caulk the area, the minute that you seal this area, any water that gets behind the siding is going to get trapped, and it will end up rotting the siding out because it has no place to go. We've got to keep these areas open so the moisture can get out of from behind the siding and not get trapped in it. And I started to see that problem with elastomeric paint. People go and they paint something like the siding with elastomeric paint, and then they seal the gaps, any gaps, and then the water has absolutely no place to go. It can't even evaporate out through the face of the siding. So that's it. If you have any questions, or if I left something out, feel free to leave a question in the comment area, and I will answer it as soon as possible. Here's a tip I'd like to share with you, and I actually got it from a viewer. They were watching a video, one of the videos I did on doweling, I believe, and they had brought up a good point that I'd share it with you. Now, here's an example of dowels that get drilled into a concrete foundation. You can see the dowel here and then a piece of rebar tying to it. Let's take a look at a few more pictures. Here they are connected, going all the way across. We have a house here and a detached garage. We went ahead and built a room addition in here. And here's the dowel, a piece of rebar, 1/2 inch, I would imagine. You drill a hole into the concrete, put some epoxy in, slide one of these babies in, and you have a dowel, a ready connection for something that's going to give you some structural strength for a concrete slab, mainly like a room addition. This wouldn't be something you would see in new construction, hopefully. Here it is again. Here's what it would look like finished. Here we have the dowels going across. Now, what I'd like to talk about is a different way to do it. Now, here is the way that I had in the pictures we just looked at. We had a dowel going into the concrete, a piece of rebar tied to it, and a piece of rebar going into the other foundation. So we had a continuous piece of rebar here and 2 separate dowels. Now, this right here would provide us with a better method, I would imagine, would provide us with a better connection. This would be taking a full length piece of rebar and then doweling it into the concrete slab and then attaching it to a dowel that is installed into the other concrete slab. It would basically eliminate one of these connections. Now, this is a great idea, and I've actually done it before, but I've had some problems. First thing I'd like to point out is that when you install a small dowel, you usually have a lot more control over it. You knock it in, you have the dowel in, and it usually isn't going to move. And remember, this stuff cannot move. So if you use a long piece of rebar for something like this, wouldn't be a bad idea to put some 2x4s or something underneath these areas, something to lay the rebar on while the epoxy is setting. You will need to set the rebar in place, and it cannot move. Problem I ran into when I did this once was that I kept on I would put the rebar in, and it sagged down. I didn't have boards supporting it, and I kicked a couple of them a few times. I mean, if you could just imagine you're trying to walk over this stuff, while you're putting the other epoxying the rest of the rebar in, and it would move. So that's not a good thing. So be careful if you are going to use this method right here. And it is actually a method I would use again, just now that I know what not to do, kind of a thing. Now, here's what the individual who got me thinking about this suggested, and I love this idea. He suggested alternating the rebar, and this is a great. Here's a question I received the other day. Thought it might make a good video. They were wondering if they could fill these joints with caulking. And I really don't see a problem with that. Using an inexpensive caulking or a caulking, some type of a polybutylene or something that's going to be a little better. Even silicone, as long as it's paintable, and make sure that's a big thing with something like this. If the siding is stained, this would be something I wouldn't recommend filling it, because the stain isn't going to match the caulking, unless you have some type of a product that will match the stain, or you're planning on painting it. And that's just, like I said, that's because it might not match. I've seen it plenty of times. I actually was just looking at a picture I had where you could tell where they stained the wood and then they filled the gaps with caulking, and it didn't look bad, but you could see where they had done it. So you could always put some type of a filler behind this, some scraps of newspaper, so that you're not using a lot of caulking. Foam, they have a foam that you can actually buy in a roll that's used for a filler. And, I'm just thinking of, instead of, filling this whole area with caulking, you could actually use some type of a filler so you're not using as much caulking. Shove the filler into the larger parts that are going to take more caulking, and then caulk it. Just seems like that'd be a good way to save some money on that. The joints, you could always fill those. Now remember, this is wood we're looking at, and you can see that it doesn't look like it's ever been filled. Wood is going to expand and contract a little more than some of the other products, like fiber cement. I don't even know if fiber cement siding expands and contracts. I think it does, because I remember putting caulking in the joints, but whether or not it moves as much, I would think that wood, masonite, products like that, plywood, they're going to move a little more than something made out of cement, especially with fiberglass. Do not caulk any horizontal joints if you have something like this where you have some Z-bar. This is actually made so that any water that gets behind the siding is going to come out of the front here, and I believe I have some more videos on that explaining that process, and you can always check out. I'll put a link in here to the siding section of our website for more ideas for the siding repairs. But there are on the website that I just I'm almost finished with. There is going to be sections, or there are going to be sections on siding and then siding repairs, framing, and then framing repairs. So make sure you check those out. And there will be links on the pages. Most of the pages will have links to make it easy for you. And I did build that website so that you can get this information a little easier, and still working on it, of course. So now here's a good example of someone caulking the butt joint, something where the siding was going to butt up against the other joint. And you can see here where the caulking has separated. And this could happen. If this is the case, pull the siding out, pull the caulking out and refill it, or just put some more caulking in, depending upon what it looks like. And I'll leave that up to you. But this is actually something you could end up with. So I would recommend contacting the manufacturer of the product for more information. They are the people who make these products, and they have more information than I could ever possibly provide you with. So that's about it for this video. Do this at your own risk. If it sounds like it'll work, you don't want to have bugs, and maybe you're getting a little too much air in something like this, it's bothering you, then why not fill it and let the siding expand and contract, and then put some more paint on it, fill the little cracks and gaps with some more caulking, and eventually I would imagine that you won't have to do it anymore. What we are looking at here is a perfectly straight wall with no imperfections at all. If we sight down it, put a level on it, straight edge, it is going to be perfectly flat in both horizontal and vertical directions. Now here's a wall that isn't very straight. It's got some nice bowed studs in it. But for illustration purposes, I went ahead and did this. Obviously, you wouldn't use a wall stud like this, but I wanted to make sure you could see what the wall was going to look like. Now, the wall is going to, if you were to put a straight edge on a wall like this, it's going to be straight in this direction. If you went vertically, it's not going to be straight. Now, the reason why I provided you with this example here was just to give you an idea of what the bowed studs look like. And this is what it would look like if all of the bowed studs were going in the same direction. All of the bows in the stud were facing outward in the same direction. Now, here's the secret to the reason why I made the video. And that was to point out the problems you're going to have if you don't crown all of your studs in the same direction. If you were going to frame a wall on the ground and then stand it up, you would simply need to sight all of the wall studs, look down the length of the stud, and see where the bow or the crown was. And obviously, if there was no bow, if the stud was nice and straight, you just simply place it. You could place it in either direction, and then if you have one that's got a slight crown or a slight bow on it, then put it face down or face up, and then run all of them in that direction. If you are stick framing, where you have the bottom plate attached to the building and you're going to put each stud in individually, then simply sight each stud, look at it, and put the crown in the same direction this way. So if you're going to frame either way on the ground or stick framing like this, then you just need to make sure that the studs are going the same direction. Trust me, this is a lifesaver for when you go to straighten all of the walls at the end, and it really does make a big difference. I did it on a room addition. I was taking my time with. Obviously, if you're in a hurry and you're not, you're the framer and you're not going to be doing the wall straightening, you don't care. But if you're the builder and you're going to be paying for all of this, then it might make a big difference. And the room addition I did really made a big difference, and the walls really turned out great. Okay, what we're looking at here is 2 toilet flappers. One is new here. Turn it over. The other is the one that we are replacing, and hopefully you can see the damage there on it. Turn it over. See if I can get some different light here in case you can't see it. You can see where it's all rough there, and of course this allows the water to run through it. So if you have a leaking toilet, there's where the toilet flapper goes. If you have a toilet that just keeps running, you need to check the toilet flapper because it's probably not getting a nice tight seal down there, and I'm having a hard time pointing to it. But that is where the rubber part of the flapper seals. It would be installed. It would install this way, go down, and create a nice tight seal. This one here, obviously, you can see where it's all damaged, so it is leaking. Here's something you need to consider before actually doing it, and that would be cutting into a public sidewalk. There are some walkways that might be private. You would need to actually verify this with the city. Another thing is not to cut into the curb or drill holes into it. It's real common to drill a hole into a curb so that you could put some site drainage in. Extremely common. Now, cutting a sidewalk, this is something that if this is a public sidewalk and it's owned by the city, and now don't be confused. There are builders who will build the sidewalk. They will build the curb. They will install the street. And then at the end of the project, they give it to the city. This is common. This is so that the builder doesn't need to maintain it. This wouldn't be a problem if this was a private walkway and the property owner maintained it. Totally different thing, which you would need to actually validate that by checking with your local building authorities. This would be the city planning department or the city building department for clarification. Now, here's one of the problems that you're going to encounter, and this is what the city doesn't want. If you're going to if they went ahead and they poured a nice concrete walkway around here, and the concrete's perfectly fine, and you take and you cut it and you install these brick pavers, and then they're sticking up a little bit, there's gaps in between it, or it starts to you start to have problems with erosion and the bricks start to sink. This creates a safety hazard that you might not have encountered with concrete. So, and that might be the reason why the city doesn't want you to do that. So if you are going to, or you would like to install something in your sidewalk, even if you want to cut the sidewalk because you're going to install something and then repair it, this is still something you would need to check with your local building authorities. Now, obviously, if this is something you don't want to deal with, you can do it over the weekend, fine, knock yourself out. But if the city ever finds out about it, you could have some problems. What would they do? I don't know. I mean, if you fixed it and it looked good, I don't really see where that would be a problem, but I'm also not the city. We were actually going to do some work on the street in front of our house, and they said that if we wanted to do the work, they wouldn't charge us for the permit. I was like, really? This all we're going to do is fill some asphalt in the front so that it looks better. We got a couple of divots in there. And they said, no, you can't do that without a permit. So that was just filling some small potholes that the city hadn't got to and still hasn't got to. It has nothing to do. You could see where something like that would be a lot smaller than something like this, cutting a section out of their sidewalk and then replacing it with something that could actually create problems for them in the future, as I pointed out in the video. Here are a few ways you can frame a corner window. We have two headers here, two sills, and they are intersecting into a king stud. And this method here would be used if you needed a little more room on the outside or the inside. Here we have a king stud and then a full-length trimmer over here, and then a king stud. It's the window sill, subsill, and the cripples or jack studs, and headers. Here we can see how the bottom is laid out. Again, two studs away. This right here is used. Most common method for using, or reason for using this type of construction method would be if you had window trim. So for example, if you were going to use wood windows and then put a 2-inch piece of trim around the window, kind of give it a picture frame look, then you would need to use something like this. You can't take and stick the windows all the way in the corner. You're going to need some room. And this method right here would be great for that. And you might even need to move it 1.5 inches further, depending upon the thickness of the window trim. In this method here, we are using a 4x4 in the corner and a full-length trimmer on each side. This would keep us 1.5 inches away from the corner. And again, this method could be used if you were going to use a certain type of wood trim, a little smaller wood trim. Would work fine for windows that something like a vinyl window or aluminum window. I say aluminum windows, I don't even know if they make them anymore. This is 2016, and who knows? I don't know when the last time was I seen an aluminum window. This would be a window with a flange and maybe a 1-inch to 2-inch, even a 3-inch, depending upon the thickness of the window and the thickness of your wall framing. It would be something that would stop in the and that would not need to be trimmed out with wood. Here's a 4x4 in the corner, and this is probably the most common method used for framing corner windows. You would have no trimmer in the corner to support the headers, because the headers would be sitting on top of the 4x4. They are mitered with a 45-degree angle. I'll show you a little bit more of that here in a few minutes. 4x4 supporting the window header, a 2x4 full-length trimmer supporting the header on this side. Here's how the bottom section would be framed so that you have plenty of backing for drywall. Upper inside corner, again sitting on the 4x4, everything dies into the corner. Here you would have a nice line coming out here, and then of course you would drywall this or trim it out with wood, however you were going to finish it. Another view here just to show you where it's supporting the 4x4. The 4x4 post is supporting the headers. Last but not least, take a look at what the mitered header would look like. You would have a header, a 4x6, 4x8 window header, and you would miter the corner with a 45-degree angle, depending upon what corner you're using. A standard corner of a home is 90 degrees. If this was going to be a different, you could use this same method for another corner type of window, but you would just need to change the angle of the header you were going to use if the wall was not intersecting at a 90-degree angle. Hope that makes sense. Here's the last example I could come up with. If you have another example or another idea, feel free to email them to me, and I will see if I can attach a link to them at the end of the video or make another video. Now this one actually uses hangers. These are inverted hangers that will attach to the 4x4. Now something else I'd like to point out here is in this example we are using a floating trimmer where the trimmer stops at the subsill and doesn't go all the way to the ground. I just wanted to give you an idea of the different trimmers that you could use. So here you can see right here, we have the trimmer sitting on top of the subsill, and here it is going all the way down to the ground. 2 hangers in the corner. I just kind of wanted to pan back here and give you another idea with the trimmers, how they're supporting the header. Header supported by a full-length trimmer, a header that is supported by a floating trimmer. What's the difference? A lot of people I worked with like to use the floating trimmer so that they could move the bottom just in case they had to. And that's a good enough reason for me right there. I like this method here. If you are building homes nice and plumb, they're plumb and level, you're not going to have everything's nice and square. This method right here would provide you with a little more support. But as you can also see, it's going to require another cripple, let's say. You know, here you can see that we only have 2. Over here we have 3. So it's going to require a little more wood to do it this way also. Take a look at the hangers. Hangers attached to the post. Nail in there, and this is an inverted hanger. You can usually find it as a Simpson HU. Again, that's an inverted hanger. The flanges are not on the outside, they are on the inside. Now here's one of the reasons why I don't like using this method, and I've seen, sometimes I've had to deal with it. Structural engineers put it in there, but the hangers usually create problems for the drywaller and whoever's going to be putting the exterior finish on, because they're usually a little bit bigger. And here you can see it's kind of sticking out here. Let's just say it's an 1/8 of an inch. I mean, a 1/16 of an inch. That's fine. That probably wouldn't be too bad, but it's going to create a little bump in the drywall, and this usually isn't a good thing all the time. So let's just see if I can kind of go out here. Another problem it's going to have is for nailing the drywall in these corners. So you could imagine when you put the drywall here, this will be the furthest you're going to be able to put a screw or a nail, and the same thing here. And I'm just going to see if I can pan around to the outside. This wouldn't be as big of a problem on the outside because you're going to be nailing over here. So, but again, the reason why I don't like using these is because they usually create a bump or a dip. And if you don't nail the hanger on correctly, then you could actually have problems. It could be sticking out even further. And of course, I've nailed these things on before where I couldn't get the beam in or the header in because I had nailed them too close together. So not a big fan of this method. I would go with the method before this one where you have where you use the mitered headers.